Thanks for introducing me. Hi everyone and welcome. In today's 20 minutes webinar, I will go through horizon tracking workflows in OpendTect and will show the amplitude-based tracking in detail. In OpendTect, we created several tools for horizon tracking. You can auto-track horizons from seismic amplitudes in the 3D scene. You can also follow a more conventional workflow of section tracking based on a grid using 2D viewers. On top of that, we have the Inversion tracker, formerly known as Unconfirmity tracker, and the extended version of it, the Inversion Plus tracker. The Inversion tracker can generate one or more horizons from a seismic depths volume, and its brother, the Inversion Plus tracker, goes beyond that and combines inversion-based flattening with event correlation. These two guys we are going to cover in the next webinar, which will take place on the 25th of June. And for now, let's start with the 3D AutoCheckin. I will switch back to the OpenTect window, and we are ready to get some hands-on experience. During this webinar, I will be using some keyboard shortcuts. As we all know, it's very handy, but sometimes can be tricky to remember them all at once. So I will advise to remember at least one of them, which is Shift plus question mark. This opens up a window which lists all the shortcuts. Now, back to AutoCheckin. The 3D AutoCheckin workflow in OpenTect always requires preloading data. So let's go ahead and preload the default seismic data, which is already pre-selected. So let's click OK. It will take a few seconds and close the window. Here you can track on inlines, crosslines, or random lines. I will start with the inline, and I will also add a new horizon to the tree. Adding a new horizon always opens up a horizon tracking settings window. We are going to take a look at it just in a second, but before that I will drop a first seed for our horizon somewhere on the peak event, like here. Now also notice that in the horizon tracking mode, the cursor is always a cross, and if you don't see the cross, you will probably not be able to start auto tracking. So for this, make sure that the horizon is selected in the tree, and then your cursor should turn into a cross and you will be able to start interpreting. Now back to the horizon tracking settings window. One thing I would like to emphasize here is that the tracking workflow is designed for conservative picking, which means less editing, as editing is the most time-consuming part. Therefore, the initial parameters are quite tight. In the first tab, the mode tab, the method, auto-tracking method is set to seed trace. This way, new positions are compared with the seed trace only and not with their adjacent neighbors. Seed-based method is usually recommended for most horizons. Another method is the adjacent parent. Next tab, the Event tab, which contains the defining parameters for section volume auto-tracking. The event type by default is set to peak, and there are other options available, of course. The threshold type is set to relative difference. Alternatively, you can set it to cut-off amplitude. And the allowed amplitude difference in percentage is set to 25, which means that AutoTracker is looking for a new sample in the neighborhood with less than 25% amplitude difference. The search window is also quite small, and you can always adjust it either by typing in a new value or using these green bars on the right-hand side. Actually, below this line over here, there are parameters which control this right-hand side panel. You can see that we picked our first seed on the this data set, and the number of traces displayed here is 5 within the from -16 to 16 milliseconds time window. Next tab is correlation. The correlation by default is always on because it makes auto-tracking more accurate, but you can also turn it off to save some time. The compare window should be quite large. The large window means more of the waveform needs to match to stay within the correlation threshold, which is also generally strict, 80% or higher, to ensure you track only high quality amplitudes. In the properties tab, there are different colors and shapes and sizes that you can change, and the deep steer tab allows to use a deep steering cube as a constraint for horizon interpretation. This will improve the horizon tracking, especially in the areas of deepened reflectors. And this option will only be available if you have a deep steering license. Now you can keep this window open or closed. And if you closed it, you can always bring it back by right-clicking on the 3D horizon, going to Tracking, change settings, or there is even a better way to do it. Hold Control key and right-click on the horizon, which brings up a special dedicated menu that contains all the useful options like auto-track, retrack, and then the very bottom of it, you can also click Change Settings, which will bring back that horizon settings window. I'm actually going to click Start Auto Tracking and see how the auto tracker works here. Let's have a look from the top. And I will click on my horizon and click V on the keyboard to switch horizon to the sections only mode. Actually, I will probably also change the horizon color, as we cannot see it very nicely. Something like this should be better, and maybe thickness a little bit also. I'm going to click on my inline and push it back and forth to QC the tracked patch. There is actually even a better way to QC from a random line. You can also in a similar way push random line back and forth, but you can also click Control, and this way you can rotate the random line in all directions. Okay, I'm satisfied with my patch, but it looks rather small, so I'm going to loosen the parameters a little bit. Let's bring back that horizon settings window, and let's have a look at the correlation tab. The compare window is set to -40 to 40, which looks too large. So you can either type in new values here, or you can use again these green bars and see how much of the waveform you would like to use to compare. Maybe I will set it to -20 to 20, and we can click Retrack All. Now the patch is a bit larger. Also, as you might have noticed, a new horizon is always added with some attributes, which are very useful for QCing purposes. I'm going to switch on the Z values so that we can see horizon is color-coded, but you can also switch attributes like amplitude, correlation, seed index. It's rather boring because we have only one seed, and tracking order. Oops. Again, I'm going to switch to the sections only mode and QC my horizon again. Same, looks good. I will click V to switch back, and what I'm going to do now, I'm going to lock this patch. For this, again, control right click on the horizon, lock. As you can see, for a few seconds it shows which part is locked in blue color. And by locking the horizon, you make sure that when tracking in other areas, the locked part always remains untouched. Of course, don't forget to save your interpretation regularly by right-clicking on the horizon, save. And let's click another seed somewhere here. Actually, I'm probably going back to the tracking settings window and changing my correlation threshold to 60% and click some more seeds. And again, control right click on the horizon, auto check. Okay, this patch is going to be significantly bigger as I changed the correlation threshold as well. Okay, looks good. And this is the 3D AutoCheckin workflow. You drop new seeds, AutoCheck, QC the patch, log, and drop new seeds and AutoCheck from those seeds. When all the high confidence areas are tracked, you may want to go back to the horizon tracking settings window, loosen the parameters a bit more, and track with the new parameters. Now here comes the useful tip. What to do if something went wrong. Of course, you always have the redo and undo buttons either in the horizon tracking settings window or from the dedicated menu. You can also use the selection and deletion tool, which are located on the left panel. But pay attention, don't try using them on the locked areas, as this won't work. So you can just select a patch and remove it. But there is another way to remove a part where something went wrong, which uses the tracking history. And for that, I prepared another horizon, which I tracked with very loose parameters. Here how it looks. Clearly lots of places where something jumped on the wrong loop. And what you'll need to do is to find a place and control right click on it and click show parents path. This pops up a 2D viewer and adds a random line to the 3D scene tree. The show parents path random line is the line from the clicked point back to the original seed. Clicked point is on the left side of the random line and the seed is on the far right. So it is best to follow the horizon in the 2D viewer from the right to the left and see where the event goes wrong. So if I'm going from my right, here's the first suspect. And what I'm going to do, I'm going to hold Control and right click on it and click select children. Let's go back to the 3D window and see that it selected the children which I'm going to remove. To remove them again, hold Ctrl, right click and delete selected. So now you can tune your parameters and retrack in this area. Now I'm going to show how to interpret the horizon in a more conventional way. I will remove this horizon and the random line as well. By a more conventional way, I mean that when you interpret on a grid with a certain step, for instance, every 10th inline and crossline, I will add a new horizon here and I will adjust the correlation parameters just as we did in the previous example. And now I will also open the Basemap. It's a very useful tool and it's also part of our commercial software OpendTect Pro. First it asks if you want to synchronize, to make sure to add all the elements that are already in the tree to the Basemap tree. In the Basemap you can click at any location and right click at any location and add an inline or crossline or both. It also displays the inline that's already in here. And what I'm going to do, I'm going to click on it and click Show in 2D. This opens a 2D viewer and I'm going to click. Again, I will change the color of the line and maybe increase the thickness, or maybe it's too much. Okay, this magenta color, I'm going to pick a few more seeds, and as we mentioned that we are going to track on every 10th inline, in this upper left corner you can set the scrolling step to 10, and of course also use these green arrows to switch back and forth, but a more convenient way is to use the shortcuts, which by default are set to Z and X for backwards and forward, but you can also always set it to your preference from the utilities settings keyboard shortcuts menu. So I'm going to click X to move forward and drop a few seeds here. Oops, this was the wrong one. If you made a mistake, you can always hold the Control key and with the left mouse click drag along the part which you want to remove it, and also if there is a difficult interval, you can switch to the manual mode, manual draw, in the horizon tracking settings window. And in the manual draw, similar to section AutoCheck, you can use either left mouse clicks, single left mouse clicks and a double click to finish it, or I'm going to hold Control left mouse click to remove, or you can just draw along the section like this. And similar controls are actually available for the section AutoCheck. I'm going to press X again and to switch to a new location. And this 2D viewer, I can open a crossline, and for this I just need to right click at any location where I want my crossline to be opened and click Show Crossline. And again, in the crossline I'm going to set the step to 10 and also use Z and X to switch back and forth. As you can see, we already have the points from our inlines, so we can just click on the crossline to interpret our horizon further. Let's switch back to the Basemap to check our horizon progress. So you can see that it was interpreted on 3 inlines and 1 crossline over here. And yeah, you can continue doing this, pop up different 2D viewers from a Basemap or from one another, and use the shortcuts not to take your eyes off of the section, and keep up with the horizon interpretation. And that was it. That was all I wanted to talk with you today. So this concludes the horizon tracking interpretation workflow. And thank you for watching, and I'm open for questions.